Hello and welcome to our next lesson in our proofs unit, working with more GCRs, addition and subtraction properties. Go ahead and pause the video if you need to fill that in. And let me jump to the actual note page. This is my page 16. So go ahead and get this title down as well, and let's jump into it. So we have more GCRs, and these are actually properties as opposed to statements, which is really, really nice because it's going to make reasoning really, really easy. And we're going to actually start off with making a nice big rectangle towards the top of a page. So let's do this. Something about like yay big, and then we're going to also draw a line through it. And we're going to have like option one, choose one, and then, so choose one, and then choose again. So you'll see what this means in a bit, because we have addition subtraction properties, and when we're talking about, let's say, an addition property, we typically go from something small to something big. So a small congruency to a big congruency. So you'll see what I mean in a minute. And then when we're talking about subtraction, we are going from something bigger to something smaller. So subtraction would be big congruency to something smaller. Okay? And it all depends on what we're working with as well. So if we have, for instance, like a diagram, let's draw a triangle. Okay? Nice big triangle off to the right. And if I have, for instance, let's say two segments that go down from the vertex, from the vertex, we could then say, for instance, if I have this segment be equal to, I have to do this in pink, don't copy this down. If I say this length is equal to 10, oh no. Oh no. So let's draw that line back in there. Okay. And for the sake of it, actually, let's do this. Let's call this H, O, R, S, and then the vertex will be E. Okay. So back to this. If I say HO is, let's say, 10, and then RS is also a length of 10, then what can you tell me about this length, HR? Well, no matter what, it's going to be equal to OR, because all you're doing is adding whatever this length measure is. If I said this measure was 4, then HR would be 14, and OS would also be 14. So that's what I mean by we're using addition properties, because we're going from something big to something small and vice versa. And that example works with segments. So we are working with either same segments or the same angle, because this also technically works for angles. We could also be talking about congruent segments or congruent angles. I'm sorry, I'm running out of room. That's what it is. So that's our options. And let's fix this just really, really quickly. Either same segment, same angle, congruent segment, or congruent angles. Those are the choices. Okay? Now, continuing with this diagram. Okay, I'm going to say given. So we're going straight into some examples. Given HO is congruent to RS. This is the example that I just provided. What can we ultimately conclude? So we have a small segment and a small segment. And we just saw that if we add this piece to both, we'll have two congruent pieces, right? So our conclusion is C, HR is going to be congruent to OS. And we have an overlapping piece. Oops. In other words, if you draw this diagram, I hate how this does this now. The overlap is what's being added. So if I highlighted this in blue, and then I highlighted this part in red, we could see the overlap being the common piece. So the reason here would be this. The reason is the addition property, because we're adding a piece to both the original segment. From HO to HR, we are adding OR. From RS to OS, we are also adding OR. So we are literally adding the same segment. And that's what we would put. Addition property, same segment. For the same segment. Okay? Now, what happens if we have something like this? Given. O angle OEH is congruent to angle RES. Okay? So OEH, we could see is this angle. Let's do blue. OEH, and then RES is this angle. Well, we could technically add on another piece to it, because what if we add this piece in the middle? Well, no matter what, if I put, for instance, put 40 degrees here, 40 degrees here because they are congruent, and then I added 10 degrees in the middle, this angle would be 50 degrees. So would this angle be 50 degrees. So we could then say, in this conclusion, HER, angle HER, is going to be congruent to angle OES. Right? And that's this angle. Okay? And this is the addition property still. But this time around, are we working? We determine what we're working with. We are working with the same angle, because this is the angle that's being added to both. This OER angle. Okay. So this is for the same angle. Okay. So let's get rid of all this pink. Not a fan of this new version of erasers. Okay, let's get rid of that one. All right, so let's try another one really, really quickly. Given, so right underneath this, HR is going to be congruent to OS. Notice that this is the converse to the statement. And notice we are going from something larger in both cases. We have an overlapping piece, OR. So what if we cut that out? We're left with HO. Okay? Then we could then say HO, conclude, HO is going to be congruent to, once you cut out OR, you're left with RS. So RS. Okay, and then in this case, we're going from something big to something small. So we would ultimately say we are using the subtraction property. So that's what this means. Let's choose one. Are we using addition or subtraction? Are we going from something big to something small? So the reason here is the subtraction property. And what are we adding or subtracting? Or what are we subtracting? We are subtracting segments, because OR is a segment. That's the piece that's getting cut out. So we're saying we are cutting out same segment. Okay? We'll talk about congruent segments. Actually, we'll talk about it right now. Subtraction property for the same segment. Now, we do need another diagram to finish this out. Okay? We're going to have one more. So, if I draw another shape, and I'm going to put P in this corner, I, G, N, O, and then E, we could then piece this together as so. Given, let's say PG is going to be congruent to NE. We're also going to say PI is going to be congruent to OE. Let's mark this before we start. PG is going to be congruent to, so the full length, is going to be congruent to NE. We also have PI congruent to OE. So if you notice, we're going from red, and we have lengths for red and blue. If I put 20 here and I put 5 here, what would you tell me about IG? And since these are congruent, we would have 20 here and 5 here. What can you tell me about NO? Well, they should be congruent. Okay, so the conclusion here would be IG is going to be congruent to NO. And this time around, the reason is subtraction still, because we're going from something big to something small. Subtraction property, but are we subtracting the same segment? In this case, no, because they are different names altogether. PI is not the same. They have the same measure as OE, but they're not the exact same segment. So this would be for congruent segments. All right, and that's all I have for you today. So we choose either it's addition or subtraction, and then we identify what are we working with. Are they the segments? Are we working with segments? If they are they the same segment, or are they congruent segments, or same angles, congruent angles? Okay? All right. If you do have any questions, please ask, and I will see you in the next one. Bye.